Good morning one and all. Myself MVS Pavan Kumar, belongs to Department of Mechanical Engineering, and today I am going to explain about heat transfer. Okay, this is the subject we are dealing in the 6th semester of Mechanical Engineering, and this heat transfer consists of 5 modules. So it consists of 5 modules. The first one is Introduction to Heat Transfer. In this we will see various types of geometries, in that how the heat transfer is going to transfer from one region to another region. And the next one, in the second module, we are going to see a steady state and unsteady state heat transfer. Okay, so in third unit we will see dimensional analysis, and the next we will go for forced convection. Okay, in the fourth module we are going to see free convection, and later we will see boiling and condensation, and finally in the fifth unit we are going to see heat exchangers, and the next part is radiation. Okay, these are the 5 modules this heat transfer consists. So briefly we will go for initially what is the heat transfer and how it is differ from thermodynamics. Already earlier we have studied thermodynamics, and we will compare this heat transfer with thermodynamics, how it differs. So if you go for thermodynamics, so here thermo means already we know heat, whereas dynamics means work. So in this thermodynamics we will convert heat into work, as well as we will convert work into heat. So but here we are going to deal with only equilibrium condition. In thermodynamics we are going to deal with only equilibrium condition. For example, consider a body A is having a temperature of 100 degrees Celsius, and the another body B is having a temperature of 50 degrees Celsius. So we kept these 2 bodies in atmosphere for some time, and later this body will lose some heat transfer, and this body will gain the heat which is rejected by body A. So obviously there will be a temperature drop from body A, as well as there is a temperature gain in the body B. And after some time the both bodies will show the same temperature. For example, 60 degrees and 60 degrees, both bodies will show the same temperature after some time. So this is nothing but equilibrium condition. Okay, but we don't know the individual temperatures before going to thermal equilibrium. Let's suppose if you consider heat transfer. Okay, here heat is nothing but form of energy, right? Whereas transfer means transmission of energy from a body to another body. A transmission is nothing but for example, consider the flow of electrons from one body to another body. So consider the same example which was already we discussed in thermodynamics. A body A is maintaining at a temperature of 100 degrees Celsius and body B is maintaining at a temperature of 50 degrees Celsius. So in thermodynamics we are restricted only for thermal equilibrium. We will know the temperature after a certain time. Both bodies will have the same temperature. For example, measurement of temperature in our body by using thermometer. So by using thermometer we can measure the temperature of our body or anything. For example, measuring the temperature of our body. So after some time the both body temperature and this thermometer temperature will shows equal, that is nothing but equilibrium, shows the same temperature. But in that scenario we are not able to calculate how much amount of heat transferred from body A to body B, as well as how much time it took to transfer heat from body A to body B. But in the case of heat transfer we can able to predict the how much amount of heat transferred during certain time, as well as we can able to calculate the body A individual temperature and body B individual temperature before they going to equilibrium. Okay, so this is the how the thermodynamics is differ from heat transfer. Okay, so heat is nothing but it is a form of energy. Transmission is nothing but transmission of energy from one region to another region. How this heat is differ from temperature? Whereas already we discussed heat is nothing but it is a form of energy, where temperature is nothing but it is a measure of degrees of coldness or hotness of a body. But whereas this is a form of energy. Okay, so if you go for heat transfer rate, heat is measured in joules because it is a form of energy, whereas temperature is measured in degrees Celsius or Kelvin or Fahrenheit, right? So what is meant by heat transfer rate? Heat transfer rate, right? Already we know it is a form of energy. Transfer means transmission of energy from one region to another region. Rate means we are comparing this heat transfer with respect to time. Means here Q by time. What are the units for Q? Already we discussed joule. What are the units for time? Joule per second. So which is nothing but watts. What is nothing but power, right? So this is based on this heat transfer is taking place based on second law of thermodynamics. Already we know zeroth law of thermodynamics, first law of thermodynamics and second law of thermodynamics. Zeroth law means if body A is thermal equilibrium with body B, thermal equilibrium means body A is having 50 degrees Celsius temperature, body B is also having 50 degrees Celsius temperature. Now this body B is also having a thermal equilibrium with body C. Means now body B and body C are thermal equilibrium with each other. Means again C is also having 50 degrees Celsius. Now we can say that the body A and body C also thermal equilibrium with each other, right? Means now we can say that A, B, C are in thermal equilibrium with each other, and this is the principle for the measurement of temperature. On this basis only we are measuring the temperature with the help of thermometer. And the next one, second law of thermodynamics. First law of thermodynamics. First law of thermodynamics. So what here? In first law of thermodynamics we can say that heat and work are mutually convertible. Okay, means, so what is the equation for first law of thermodynamics? dq equal to du plus dw. Means we can convert heat into work or work into heat. Okay, this is about the first law of thermodynamics. If you go for second law of thermodynamics, it consists of two statements. Okay, second law of thermodynamics. The first one is Clausius statement, and the next one is Kelvin-Planck statement. Okay, what is a Clausius statement? A Clausius statement states that it is impossible to transfer heat from cold body to hot body. Means it is not possible to transfer heat from cold body to hot body. Means it is possible to transfer heat from hot body to cold body. That is a natural process. How? The water flows from higher region to lower region. If you want to pump the water from lower region to higher region, we are supposed to use a pump to transfer from lower region to higher region. In this scenario also, if you transfer heat from cold body to hot body, we need an external assistance. Example, heat pump and a refrigerator, right? So on this principle, Clausius statement principle, the heat transfer is taking place. Means heat is always takes place from higher temperature region to lower temperature region only. Higher temperature region to lower temperature region. Then what about Kelvin-Planck statement? So this statement states that it is impossible to construct a machine which gives 100% efficiency, which is working at a single thermal reservoir. Okay, let's suppose consider a heat engine which is working at two reservoirs, and we are obtaining some work output, and this is a Q2. Okay, this is the actual heat engine working, but this statement states that it is impossible to construct a machine which is having single thermal reservoir. Means the heat which is we are extracting from the source T1, that is a Q1, which is equal to output W, but it is not possible. Okay, this is about a Kelvin-Planck statement and a Clausius statement, right? When this heat transfer is possible, okay, when this heat transfer is possible, let's suppose consider a body is maintaining at a temperature of 100 degrees Celsius and body B is maintaining at 100 degrees Celsius. Now is there any chance to transfer heat from body A to body B? No, because these two are thermal equilibrium with each other, right? Because the body is having 100 degrees Celsius, body B also having 100 degrees Celsius. Then when this heat transfer is possible, if any one of the body is having lower temperature when compared to other, suppose 80 degrees Celsius, no body. Now there is a now heat transfer takes place from body A to body B because there is a temperature difference between body A and body B. What is the reason for heat transfer? Due to the temperature difference, right? So in this heat transfer there are three different modes of heat transfer. The first one is conduction. This heat transfer takes place via three modes. In this, the first one is conduction, and the next one is convection, and the third one is radiation. So the heat transfer takes place via these three modes: conduction, convection, radiation. Now we will see one by one how the heat transfer is taking place in each mode and what is the mechanism involved in each mode. Now if you consider conduction, it is one of the modes of heat transfer. Okay, the heat transfer is taking place via solid medium. Let's suppose consider a metal rod, and here we are supplying some amount of heat to this. Then after certain time we can observe or we can experience the heat transferred from this region to this region. Means we can observe the hotness at the other end. This is the one. And the another thing is, if the body A is kept contact with body B and these two bodies are maintaining at different temperatures, means let's suppose 50 degrees Celsius and this is 30 degrees Celsius. So because the body A and body B kept contact with each other, there is a possibility to transfer heat from body A to body B because here there is a temperature difference exists. Okay, so there are two conditions within the body itself, or if from one body to another body, this physical contact must be compulsory, right? Okay, so what is the mechanism involved in this conduction? Now what is the reason for the transfer of heat from one region to another region? The first one is due to lattice vibration. And the second one is due to transfer of free electrons. So what is meant by lattice vibrations? So in conduction we consider a medium as a solid. In solid the atoms are packed very closely, right or not? As we are supplying heat at one end, the energy absorbed by or gained by one atom which is having a higher energy is try to give the energy which is having excess to the next one. Suppose this is the atom and this is another atom. This is having a higher energy. Due to this, this is going to transfer heat from this atom to this atom, means colliding with each other, and this atom next absorbs some amount of energy and excess energy will be given to the next atom. So in this way the transfer of heat from one region to another region, this is due to lattice vibrations, because this is a solid medium. And the transport of free electrons. So already we know higher orbit electrons are always trying to go for lower levels, higher level to lower levels, and the second one is due to that one. Okay, so what is into conduction? If the heat transfer is taking place via medium solid, then we can consider it as a conduction, right? And the next one is convection. So in convection, the medium is compulsory to be existed. The medium will be fluid. Fluid means it consists of liquids, so fluids, liquids and gases. If the heat transfer is taking place via fluids, then we can consider it as convection. So what is the reason or what is the mechanism involved the heat transfer in convection? Like we consider here in conduction, lattice vibration as well as the transport of free electrons. So in this scenario, so the reason behind that is, okay, so for this we will have a small example. Let us consider we are boiling water in a bowl, okay, and we are supplying heat from bottom, right? Initially this water is at atmospheric pressure, means 1 bar. As we are initially the temperature will be equal to atmospheric temperature. As we are supplying the heat, let us consider this water is in the form of layer by layer, right? The first initial, the bottom layer which is having contact with this bowl will get heated up. Due to this heating, the density of this layer gets lowered. What happens if the density lower? This will try to transfer to the upper portion, right? And the higher density, which is having higher density layer, will go downwards. In this way, the heat transfer is taking place. What is the reason here? Due to the transfer of layer from one region to another region, due to density difference. Due to density difference, right? So due to density difference, what happens? Convection currents created. That is a transfer of higher density layer to downwards, whereas a lower density layer to upwards. So this is nothing but buoyancy. Okay, this is the reason how the convection will take place. The simple example is boiling of water or cooling a hot water and keeping that hot water in atmosphere. And the next one is convection. If the radiation is not taking place with the convection and conduction, then it is absolutely radiation. Okay, here in radiation there is no need of any medium, whereas if you go for conduction, the conduction majorly 90% predominantly takes place in solids only, right? Whereas in convection, fluids only. Whereas in radiation, there is no need such type of medium. Then which what is the medium? There is no any kind of solid body as well as fluid. So vacuum is the what we'll call it as like a medium. Here there is no any medium, but in vacuum this radiation heat transfer takes place. Vacuum means there is no anything, it is a completely emptied. Okay, if the heat transfer is taking place through vacuum, then we will call it as a radiation. For example, I think in childhood days we have played with the magnifying lens, right? So we will keep this magnifying lens under the sun, the sun rays will fall on this magnifying lens and it will be collected as a point type collector. Okay, and the rays which are collected at one point transferred to another end, and we will I think we enjoyed by keeping a piece of paper, and after some time this paper will get burned. So here we kept a mirror, right or not? Lens. This lens will obstruct the flow of medium, and here there is no any solid body contact with the paper, even though the paper get burned. Okay, so here we can observe that there is no any medium, only in a vacuum radiation of heat transfer will takes place, right? So this is about conduction, convection and radiation, right? So in this the next one is Fourier law of heat conduction. Fourier law of heat conduction. So we are seeing first conduction, later we will go for convection and radiation. Fourier's law of conduction. What it says, let's suppose consider the rate of amount of heat flow, that is we will denote with the Q, is directly proportional to the, okay, directly proportional to the area in which perpendicular to the direction of heat flow as well as temperature difference of that body, means the temperature difference between two faces of the body and inversely proportional to the thickness of that body. We will see with the diagram, right? Let us consider a body which is having a thickness of dx, right, and this body is maintaining a temperature difference, that is dt. Okay, this is nothing but dt. Now Q is flowing in this direction, so we are supposed to consider this phase. The rate of heat flow is directly proportional to the, in which the heat is flowing perpendicular to the phase, perpendicular to the phase, this phase, this phase. Now heat is flowing perpendicular to this phase, right, and as well as directly proportional to the temperature difference of that body and inversely proportional to the thickness of that body, right. So to remove this proportionality constant, we introduced a new term called thermal conductivity, that is denoted by K, remaining everything is same, minus Ka into dt by dx. Then what about this minus? Why you have kept minus here? What that minus sign indicates? What that minus sign indicates? Okay. So if you go, as the thickness of the body increases, means as we increase the thickness, that is dx, there is a drop in temperature, right or not? There is a drop in temperature. That is the reason why you have kept minus here. Then how this minus will get positive? In positive x direction, always this is called as temperature gradient, always negative. Let us consider dt. If you apply limits, we will use dt, integrate it 1 to 2. Okay, what we will see if we integrate it, we will get t limits to 1, t2 minus t1, means we are subtracting it from lower value to higher value, because T2 will be lower, T1 will be higher, and here we will get minus, and this minus and minus will be, it will be positive, right? And finally we have an equation Ka into dt by dx. This is our Fourier's law of heat conduction. Okay. So in this we are going to deal with different coordinates, means in different geometries. Means the first one is how the heat transfer is taking place in Cartesian coordinates. And the next one is cylindrical coordinates. And the next one is spherical coordinates. The example for Cartesian coordinates geometries are rectangular cross sections. For example, so in this type of geometry, how the heat transfer is going to take place in three coordinates, means x, y and z. How the heat transfer is going to take place in this type of geometries we will see in Cartesian coordinates. And next, cylindrical coordinates, means in cylinders. How the heat transfer is taking place in cylinders. For example, consider cylinder. Okay, here the coordinates are x, y, and z axis. Okay, coordinates are x, y, z. Whereas in cylindrical we have the coordinates are r, theta, z. These are r, theta, z. From here to here there will be radius. To complete one revolution we need some angle, that is theta, and the height will be z, right? These are the three coordinates in cylindrical. While coming to spherical, sphere. Okay, in sphere we have three coordinates. What are they? R, theta, pi, where we will use these coordinates, or how the heat transfer is taking place in this type of geometries. The applications are in rectangular vessels, industries. If we kept something, any fluid or gas, how the heat transfer is going to take place in rectangular vessels, cylindrical vessels, whereas in spherical vessels. If you have any idea, or if you have if you visited to BHPV, Bharat Heavy Pressure Vessels Limited, you can observe these type of vessels there. Okay, with the help of these three we will see how the heat transfer is taking place in three different geometries. Okay. So, enough, sir. Enough, sir.
He said thank you something.
No.
say thank you, watch the video, make the notes. From web page you explain?
No sir, no need sir.
Come in center and you just say okay. From that side only, last you said that side. Huh? Come this side. This side. I say this was watch the video, put the assignment, give attendance in the comments. Thank you.
Okay. So please watch this video and complete the assignment. Okay. Thank you.